Hello, everyone. Welcome to Unit 3, Lesson 6. We are going to be talking about product and quotient rule with negative exponents today. So our goals are pretty much the same as they were before when we talked about the product and quotient rules before. We want to be able to expand exponential expressions and then condense or simplify them and use the product and quotient rules to simplify exponential expressions. It's just this time we're going to have negative exponents that might occur. Okay, so let's take a look here at the first one. So what are negative exponents? Where do they come from? Negative exponents usually arise when we are attempting to simplify an expression that is a fraction. All right, so we're looking at something like this, right? This is a fraction, and I have a base of 2 that's being raised to the third power in the top, and a base of 2 that's being raised to the fifth power in the bottom. You might be thinking, we know about the quotient rule. We could subtract those two exponents and write this. But this one is a little bit different because if you notice, the number in the top is smaller than the number in the bottom. Right? So if I were to apply, let's say that exponent rule, the quotient rule that we have used before, right? We would write this as 2 raised to the 3 minus 5, right? We would take 3 minus 5 and we would get 2 to the negative 2 power, right? And that's kind of weird, right? How do we get 2 to the negative 2? Well, let's look at what happens when we look at the expanded version of this expression. Okay, so we say 2 to the third is 2 times 2 times 2 over, and then in the bottom we get 2 times 2 times 2 times 2 times 2, right? So we've got a repeated multiplication 3 times in the top and repeated multiplication of 2 5 times in the bottom. And then we can cancel things out, right? Because 2 divided by 2 is simply 1. Here's another 1, and here's another 1, right? So in the top, right, if I were to write this thing in its simplified form, we would have 1 times 1 times 1, which is 1. And then in the bottom, right, you have 1 times 1 times 1, which is just 1. But then really all we have left is 2 times 2, right, which is the same thing as saying 2 squared, okay? And then we can simplify it even a little bit more because we can actually evaluate 2 to the second. So we can say 2 to the second is just 4. So we can rewrite this as 1 over 4. Okay, so there's a number of different ways, which is kind of weird with the negative exponents. So we have 1 over 2 squared, 1 over 4, and this is also equal to 2 to the negative second power. Okay, so let's look at that with variables and do the same thing with variables, right? So again, if we apply the exponent rule here, we would get x to the negative second, and this is okay. On some problems, you can write it with a negative exponent. If we were to expand, we would get x times x in the top, and then we would get x times x times x times x times x in the bottom. Okay, so that means the x's would cancel, and what we're left with is a 1 in the top, and then an x times x in the bottom, which is x squared. But because this one's x, we can't do what we did up here. We can't evaluate this, but we can say 1 over x squared is the same thing as x to the negative second, right? And this kind of brings up a pattern here, so we can rewrite something with a negative exponent, right? So for instance, if I had x to the negative third, what I could do is pretend that this is over 1, flip it, right? So if you notice what happens here, we flip this, and we can say 1 over x to the third, right? So we flip it and change the exponent to a positive number when we do the flip. Okay? So a little bit of flipping going on there. All right, so let's try it with a few more expressions. All right, so we got a couple more going on here. So similar to what we did up at the top, and this time again with 2. So we're going to have 2 times 2 on the top, and then a 2 times 2 times 2 times 2 times 2 times 2 in the bottom. All right, so we got these two canceling out here, so we can see 2 sets of the 2's cancel, and we get a 1 in the top, and then 2 times 2 times 2 times 2, which is 2 to the 4th in the bottom. Okay. So then if I were writing this in its exponential form, I have two options. I could write this as 1 over 2 to the 4th, or I can write this as 2 to the negative 4th. Right, because 2 minus 6 using that quotient rule. Right, if I did 2 minus 6, we would get negative 4. Then we can do the same thing here, right? If I applied the exponent rule, we would get x to the negative fourth power. And if I were to expand, right, we get x times x, and then the bottom we get x times x times x times x times x times x. And we cancel those out, and we get 1 over x to the fourth. All right, so we can write 1 over x to the fourth, or we can write x to the negative fourth. And again, we see that flip, right? If I were to put this over 1, right, we would see this simply flipped, and then the exponent changed to a positive. All right, so let's take a look at an example that has multiple variables, right? So we have an a and a b going on here. So let's focus on just the a's for a second here. Like, pretend the b's don't exist, and let's just focus on the a's. Okay, so if I were to expand this out, we would get a times a over a times a times a times a times a. Then we're going to do the b's, right? So then I have b times b times b. And then down here we'll have 4 of them, b times b times b times b. Right? And then we can cancel some things out, right? So we have a set of a's canceling, we have another set of a's canceling, we have a set of b's, another set of b's, another set of b's, and let's take a look at what we have left here. So in the top, these are all just ones, so we get a 1 in the top. And then in the bottom, it looks like all I have left is 1, 2, 3 a's, so we're going to say a to the third, and then we have a b, right? So a to the third times b. All right, so this is definitely one way that we could write it. The other way is to go ahead and apply the quotient rule and say, okay, well, if I do a squared over a to the fifth, I can subtract the 2 and the 5. So I could say, well, that is a to the negative third times, and then over here with the b's, if I do the quotient rule on the b's, we would do 3 minus 4, which is negative 1. Right, so we could say times b to the negative first. All right, so either way, like this, these are both acceptable answers. You might run into some problems where they say leave your answers with no negative exponents, in which case you would just do a flip on each one, right? So for instance, a to the negative third would equal 1 over a to the third times, and then you would do the same thing with b, right? It's because b to the negative first is the same thing as 1 over b to the first. So you'd say 1 over b to the first, which is essentially what we have down here. 1 times 1 is 1, and then a third times b to the first is just a to the third times b to the first. This is what we had here in the first place. All right, so either one of these, good. All right, let's do some more simplifying here. So like when we get to the larger exponents like this, where we have like 10s and 23s and things like that, it is much easier to just go ahead and use that quotient rule to help us out, so we know that we can subtract these things. So we know we're going to have a base of x, and if I do 11 minus 15, well, that's going to be negative 4. So I can write it as x to the negative fourth, or I can do the flip and write it as 1 over x to the fourth power. Okay, so again, either one of those is fine. Let's do it again here. So y's, right, same base. Quotient rule means I'm going to subtract those two exponents. We're going to do 10 minus 23, so that's going to be y to the negative 13th, or I can write that as 1 over y to the positive 13th. Again, just visualizing that flip, right? Just flip it over, change the exponent to a positive number. All right, one more time, this time again with multiple variables. We'll take care of the a first. So I do 13, right, minus 16. So we're going to say that is a to the negative third times, and then we do the b. So we do 22 minus 28. So that is b to the negative 6. So this is a good way to write it. I could also do the flip, right, where I put this over 1. Right, so this would turn into an a to the positive 3 in the bottom and a b to the positive 6 in the bottom. So this would be equivalent to this. All right, let's look at some product rule. All right, product rule. So remember, when we multiply two things with the same base, we can add the exponents together. So this would actually be x to the negative 5 plus 3, whatever that turns out to be. Well, negative 5 plus 3 is negative 2, so this would be x to the negative second power. All right, so we'd say in exponential form, we could write this as x to the negative second, or we could write it as 1 over x squared. Right? Either one of those are fine. Okay. I'm going to go here, we do the same thing. Remember, you can only do it with things that have the same base, right? So we can only combine the a's, right? So if I do a to the negative third times a to the second, I can add those exponents. I can add the negative 3 and the positive 2, and negative 3 plus 2 is negative 1. So I can say, and here we can say a to the negative first times, and then go back here and let's do the b's. All right, so this one is a positive 4, this one has a negative 5, so 4 plus negative 5 is again a negative 1. So we're going to get b to the negative first, and then I could write that doing the flip on each one. So it's be 1 over a times, and then you could do another one. You don't really need a second one up here, but if you do the flip on the b, you're just going to get b in the bottom. All right, so it'd be a to the positive 1 times b to the positive 1 in the bottom of the fraction. All right, let's do it with some larger exponents. All right, those exponent rules really come in handy for the big ones, right? So if I do 22 plus negative 15, well, that's going to be a positive 7, so we just get x to the positive 7 here. No flip required because our exponent turned out to be positive here, right? So we'll do the y's here. So y's same base. 12 plus negative 14 is negative 2, so we get y to the negative second power, or we can say 1 over y squared. Let me go here. Same thing that we did before with this one, right? Do your A's first. I like to highlight my A's and then highlight my B's. Right, so that way I handle those separately. I like color coding things and keeping things organized. All right, so I'm gonna do the A's, right? So 12 plus negative 13, well, that's negative 1, so we get a to the negative first, and then b to the 8th, so that's 8 plus a negative 22, so that's negative 14, so we're gonna times b to the negative 14th power. Or we do 1 over, right? Or this whole thing is over 1, so we can just flip those and say, okay, this is a to the first times b to the 14th, and write it like this. All right, guys, that's it for today's lesson. Give the practice problem a try, see what you can do. Make sure you ask any clarifying questions in the Zoom chat. Have a great day.